So I'm going to introduce you to a unit that we didn't use much in Chem 1A. First of all, the unit that we all know and love, the mole, right? We use moles all of the time, and this is my little stuffed mole. His name is Avogadro. And this is his friend, Milli mole. Isn't she cute? He's a little tiny mole. Because what does Milli mean? Times 10 to the minus 3. So her name is Milli. Milli mole. So in this class, millimoles are going to be much easier to use than moles. And so in the worksheet that we're working on today, there are several questions that ask you for an answer in millimoles. There are several questions where if you use millimoles, the math is very simple, and if you don't, it gets more complicated. So I want to explain this to all of you. So a mole and a millimole. This is just the milli prefix, which means times 10 to the minus 3. We're familiar with it in front of liters and grams. You could put it in front of anything. Milliseconds is also commonly used. So our concentrations are almost always going to be in molarity, right? Or say, oh, we've got 25 milliliters of 5 molar HCl. Okay? Well, what does that capital M mean? Moles over liters, right? That's 5.0 moles divided by liters. Now, if I multiplied this by 2 divided by 2, would that change anything? No, because 2 divided by 2 is equal to 1. Those would cancel out. If I put milli in here and milli down there, does that really change anything? No. No, it doesn't. Because milli just means 10 to the minus 3. So I've got 10 to the minus 3 moles per 10 to the minus 3 liters. And those prefixes can cancel out as well. So the millis could cancel out. It's still moles per liter. So everybody okay with that? I know it's kind of a leap. Okay, so if we want to find out how many moles of this we have, we can take our 25 milliliters, and normally you would convert that to liters, which is, well, not necessarily fraught with peril, but it goes sideways a lot because people move the decimal point the wrong way, or they accidentally do it 2 places instead of 1. A common answer for this one in liters is 0.25 liters, and it should be 0.025. So we can make a lot of mistakes there. Let's just leave it in milliliters. So we're going to multiply by our molarity. And we have a problem because milliliters don't cancel liters. I should have put this a little further away. So, yeah, that's better. Well, we can multiply the top by 10 to the minus 3 and the bottom by 10 to the minus 3. We did the same thing to the top and the bottom. It still represents the same concentration. Now, milliliters cancel. I should have used nicer numbers. 25 times 5. 125. So we get 125 millimoles as our answer. We're going to do a lot of calculations where we need to find the number of moles, and then we do some things with that, but then we end up with molarity at the end. So this is in millimoles. We can do the calculations exactly the same as we would with moles. You can do stoichiometry using millimoles. What's nice about this is maybe this was a dilution problem, and we're taking 25 milliliters of 5 molar HCl, and we're diluting to 100 milliliters. That's pretty common, right? Because We don't use large quantities in the chemistry lab. Well, if I want to find the molarity of this in 100 milliliters, 125 millimoles divided by 100 milliliters. So the math comes out to be 0.125, and just cancel out those millis, and you have molarity. Yeah? If we're like doing stoichiometry, I'll just make something up. We got a titration, sodium hydroxide, sulfuric acid, and maybe it takes 10 milliliters of this, and it was 0.10 molar, and we had 25 milliliters of the sulfuric acid, and we're trying to figure out what the molarity is. This is a stoichiometry problem. And so the starting point for stoichiometry, I did not plan my space here because I didn't plan anything. I'm going to start writing up here. The starting point for stoichiometry is grams to moles to grams. And in my 1A class, we chanted that for a while. Grams to moles to grams, and some of you had nightmares about it. That's where you start, and then you see what you've got and you make adjustments. So in this problem, I'm given a volume and concentration of sodium hydroxide. I'm not given a mass. So what I'm going to do is I'm going to have milliliters here. We did this in 1A. And we would convert milliliters to liters to moles, right? Well, didn't leave much space here, but we could go milliliters to millimoles, and then we don't want a mass at the end. We want the molarity of the sulfuric acid. So we'll take our millimoles that we get and divide by the volume in milliliters, and we'll get molarity without doing any conversion factors. .0 milliliters, sodium hydroxide. I'm going to write all this out because I know there is one or two stoichiometry problems on the worksheet, and, you know, it was a long summer. And so we're going to go to millimoles of sodium hydroxide per milliliter of sodium hydroxide. So what is that? That's moles per liter. That's the molarity. I'm just sticking milli in here to make life easier for myself. The concentration was 0.10 moles per liter. My milliliters of sodium hydroxide cancel out. I have to convert my millimoles of sodium hydroxide. Let's do it this way. Normally, we would put in moles of sulfuric acid per moles of sodium hydroxide. And it's 1 mole of sulfuric acid to 2 moles, 1 mole to 2 moles. But I can throw milli in there, and it doesn't change anything. So millimoles are canceling. And so I'm going to get my millimoles of sulfuric acid. So I've got 10 times 0.1 divided by 2. 0.50 millimoles of H2SO4. I had 25 milliliters of this. Okay. So 0.50 millimoles divided by 25 milliliters. Zero, it's not a good zero. did it again, 0.02, and cancel those millis out. We got molarity. So using millimole, because we use milliliter so much, is going to save us from doing a lot of converting back and forth. And anytime you do something, you have a chance to make a mistake. The other reason that it's especially helpful in this class is a lot of times we're not going to have numbers of moles that are fairly large. If we did this in moles, right, this many millimoles, if we convert that to moles, right, .00050 moles. We're going to do a lot of problems where in millimoles we end up with like 0.005. If it was in moles, then we've got 0.000005, and we have to use scientific notation or count zeros all the time. It's inconvenient. When we've got small amounts of moles, using millimoles gives us numbers that we can write in decimal notation. It's just so much easier. So please use millimoles on the worksheet and ask me lots of questions. Any questions? Yeah.
So on the milliliters and the NaOH, when you cancel it out with the millimoles, you don't have to put anything down there to cancel out, or there's no fraction.
Right here?
No, on the left, go down to the right.
Here?
No, left. Down. There's a number that goes in front of that.
Correct. This is the concentration. So 0.1 capital M is 0.1 moles per 1 liter, or 0.1 millimoles per 1 milliliter. And you can always put a 1 down there. That's a good question. Anybody else?